Let's look at this. Here's another example. This is actually for introductory chemistry. You should know how to do this already, but nonetheless, we'll go ahead and do it. What we have this example involved. What is the total vapor pressure above a solution that contains hexane and cyclohexane? Gives the amount in grams of those two compounds. The vapor pressures give the vapor pressures of the pure substances. Assume ideal behavior. So the total vapor pressure, that's what we want, is equal to the mole fraction of hexane times the vapor pressure of pure hexane plus the mole fraction of cyclohexane times the vapor pressure of pure cyclohexane. A number of moles of hexane, that will be the 21.55 gram. The molar mass of hexane, 86.18 gram per mole. So this is 0.25 mole of hexane. Do the same thing for cyclohexane. The mass given to the problem was 64.14 gram. Divided by the molar mass of cyclohexane is 84.16 gram per mole. Number of moles of hexane, 0.762 of cyclohexane. So the mole fraction of hexane is the moles of hexane divided by the total moles, and that comes out to be about 0.25 to two significant figures. And similarly, the moles of cyclohexane, you do that or just subtract this, only two components, so 1 minus 0.25 is 0.75. So there's your mole fractions. The vapor pressure of the pure substances was given in the problem. So the pressure is equal to the mole fraction of hexane, 0.25, times the vapor pressure of pure hexane, given the problem, 151.4 millimeter mercury, plus the mole fraction of cyclohexane, which is 0.75, times the vapor pressure of pure hexane, given the problem, 77.6 millimeter mercury. So the total pressure comes out to be 96 millimeter mercury. All right, so that should be familiar. Maybe you remember that from introductory chemistry. Now, what are the mole fraction of hexane and cyclohexane in the vapor? Oh, well, just let's see here. This is the total pressure, and we use the mole fractions in the solution. So what are the mole fractions in the vapor? Well, we go back. I'll just show you what we did here. Y1 as a function of x1. So I'll just write that equation, sort of translate it. 1 will be hexane, and 2 will be cyclohexane. So the mole fraction of hexane in the vapor phase will be the mole fraction of hexane in the liquid phase times the vapor pressure of hexane pure divided by the vapor pressure of pure hexane minus the vapor pressure of pure cyclohexane times the mole fraction of hexane plus vapor pressure of pure cyclohexane. Put those numbers in. Let's see, mole fraction of hexane was 0.25. Vapor pressure of pure hexane 115.5. I'll omit the units. Down here we have, sorry, it wasn't 115, it's 151. 151.4 over, and the difference in vapor pressure is 151.4 minus 77.6 times the mole fraction of hexane, 0.25, plus the vapor pressure of pure cyclohexane, 77.6. So this comes out to be 0.61. So note that the mole fraction of hexane in the liquid phase is 0.25, but the mole fraction of hexane in the vapor phase is 0.61. Is that what we expect? Well, yeah. Hexane has a bigger vapor pressure, so you would think that would have a bigger contribution to the vapor phase than cyclohexane, which is less volatile. So that seems to check out. All right, so that ends this part of the lecture, and if you're still with us, we'll try for the next part of this lecture 11.